Today on Teardown, I'm going to radically disassemble a BenQ model SP820. This is a DLP projector, so it should be a little different than the three-way LCD projectors I tore down earlier this week. Hopefully we can see some differences in the assembly because of that. So from 2008ish, so it's a pretty early DLP projector. And usually the DMDs look pretty cool in the older stuff compared to the new. Oh, let's see what we get. Oh, well, that's fine. We don't need this on anymore. That should be all the screws needed to pull the top cover off. The screws in the handle, they're pretty much all stripped in the plastic, so they're not going to come out. Well, they're going to come out. They're just not going to come out the proper way. Wait, not a problem. A little speaker in there. I remember the first time you saw a silver speaker like that, it was in an Apple product, wasn't it? You know I'm right. Alright, let's take the logic board out. Nice EMI shielding on the top. Nice attention to detail. The build quality on this projector is actually pretty good. Screw. Alright, that looks like everything. Let's pull this EMI shielding off. See if there's anything in there that looks cool. Now I see this little screw right there. You got me. You got me again. There you go. Let's see what we have here. This looks like something that would say Sony. Oh, no, it's a Texas Instruments DLP chip. So that's the actual DLP chip. The thing inside is the DMD, digital micromirror. So let's come out. One more screw underneath the shielding there. All right, now. Oh, looks like I'm gonna have to undo the back panel section too. How about now? There we go. Well, that's a nice assembly. I like the use of standoffs to hold the boards together. There's a port interconnect right there. Is that soldered? No, it's not. Throw that off to the side because, as per usual, I'm interested in the optics. That's what I'm here for, and I have my priorities. So let's try to get into that. Yeah, it looks like the optical assembly is just held on by 4 screws in this area. So hopefully I'll be able to pull that whole thing up and out after those are undone. Then we can take a look at the optical train. See how it all works. Is that it? I think so. No, I was wrong. Let's see. I think I'm gonna have to dig pretty deep to get to the optical assembly. It's a pretty simple optical assembly by the looks of it, though. Probably just gonna be a kaleidoscopic beam homogenizer color wheel, a couple of lenses, the DMD, and then the focus zoom mechanism up in the front. Remove this screw because it's here, and we can. Flip band. Boy, how many extra screws does this thing have? Lots, apparently. There's the lamp driver. Looks like another, oh no, 4 MOSFETs. Oh, it looks like it is a full bridge lamp driver. Yeah, all the gate drive ICs, probably 2 like half bridge drivers or something. But yeah, nice full bridge driver for the lamp inverter ballast. I like it. Nice. All right, let's take out the main power supply now at this point, because it looks pretty accessible. And it's a great form factor. It's a rectangle and not a goofy shape like many projector power supplies tend to be. There's something nice and aesthetically appealing about having a power supply that doesn't look like a nation state. Alright, so this is the main power supply. You got the AC mains input here, and then we have these, and that's the high voltage DC output to the lamp driver, usually like what, 170-ish volts. And you got the low side output with the power supply, so it's like 5 through 24 volts comes out of there, but it's nice form factor. That's a very useful power supply right there. Looks at a pretty decent low side current too, so that's always nice to see. Okay, now we pretty much just have the optical engine left. It's still not ready to come out. Oh, there's a screw buried way down in there. How am I going to get to that? I think I got it. I got it. I think that was it. Oh, come on. Seriously? What are you held in by? Hopes and dreams? Those are some strong hopes and dreams. Nope, this is just coming out right now. You see this? That one screw. That one screw is buried underneath there. What do they use? Psychic powers to put that screw in? telekinetic screw turning. I am disapproved. And this is disassemble. Brute force. Well, it's bent, but that's okay. I'm happy with it. Look at that dust. Woo! That's a dusty color wheel. Dusty color wheel. Let's pull the heatsink assembly off. Alright, so here's the GMD daughter board. So the GMD makes contact on the back of there. This is the heat plate. So that goes through the board. Go ahead and pull that off. That connects to the heatsink and a heat pipe assembly out there in the back. That's what keeps the digital micromirror cool. Put that off to the side. Let's take a look at the optical assembly a little bit more. It's pretty much a all one kind of solid piece they lay the optics in. But anyway, the light from the lamp comes in here, and on the inside there are 4 mirrors, and that makes the kaleidoscopic beam homogenizer. And then we have this right here. That's the color wheel. The color wheel spins around, and it gives you your sequential colors. So that section, there's no light being filtered, so it's a white light. This one right here is actually blue. So if we look through there, see that the blue light comes through. Got the red. Got a little section of yellow right here at the top, and then got the green. So as the light is going through the color wheel, it gets its colors sequentially. So red, green, blue, yellow, white, red, green, blue, yellow, white as it spins. And that light, as I said, gets sent into the kaleidoscope beam homogenizer. It works exactly the same way, or does the same thing as the lenslet array beam homogenizer does. Well, let's go ahead and we can take out the DMD. Actually, at this point. So that's the digital micromirror device. Take a look at that. And these use electrostatics to drive hundreds of thousands of little mirrors on the surface. In some of my Pico projector teardowns, I actually show these running under a microscope. If you're interested to see one of these in operation, they're really cool, and it is fascinating to see the surface of a chip actually produce an image. It's about the closest thing to alien technology you can really see in person. It's quite odd. Alright, time to take off the color wheel. This should be the tachyo sensor, and this has a little optical sensor right there. And what this does is it picks up a reflection off the color wheel or marker. So if I rotate this, yeah, right there, you see that dark portion? So as that dark portion goes by, that optical sensor gets triggered. So it would be 1 rotation, 2 rotation, 3 rotations, so on. Alright, color wheel. Looks like this bracket actually gets removed by those 2 screws. So there's the color wheel. Very dirty color wheel. Alright, let me see if I can get you the kaleidoscopic beam homogenizer. Show you that. Get off. Nope, I may have to do those two little screws too. Get in there. There we go. Alright, so this is the beam homogenizer. There's 4 mirrors. Well, each surface has a mirror. Can I show you that? So there's a mirror, there's a mirror, there's a mirror, there's a mirror. And those will help make the light distribution, the intensity, more even. So for example, if I take this and I shine a light through it, I'll have this blue LED light right here. You can see that it's brighter in the center, and it gets gradually more dark as it goes out. Well, I shine the light through the homogenizer now. See what we get. And you can see that it tries to make the distribution more even. It's not exactly the right light to shine in, but kind of get the idea. It has the same square kind of output as the lens arrays does. Alright, continuing on. So, after the beam homogenizer, we got a focusing lens, a condensing lens. That squeezes down the light even more. It goes in through this section right here and hits the first surface mirror. And that'll be under that tape right there. If I remove the first surface mirror from that, we'll be able to see where it actually enters into the DMD. Go ahead and remove that. Little screwdriver, that'll work. Oh, it's also glued in. No. There we go. Didn't break into a billion pieces. Alright, so the light from the homogenizer comes in this way. Through here, hits that mirror that I just pulled out. After it hits that mirror, it gets reflected this way towards that lens on the inside. You see right here? My finger's behind it. The DMD sits in that area. I'll kind of put that there for the moment. And reflects the light back out towards the front of the lens here. So if I tilt this at the right angle, you should be able to see there's the DMD. If I remove it, now you can see right through there. So it's a very simple optical mechanism. As I said, basically a light source, a color wheel, then you got the beam homogenizer, a lens, one mirror, the DMD, and your output optics. Not much to this at all. Yeah, very simple. Not as much fun as the 3-way LCDs are to take apart, but that's the way it is. About the best thing in this projector, probably this power supply. It's a nice power supply, and definitely useful. Anyway, I'm gonna continue on with pulling out the fans, and once I get those all removed, we'll take a look at everything I pulled out and see what we have. Alright, let's take a look at all the parts that I pulled out of the DLP projector, starting with the optics. So, got the color wheel, and it has the acrylic filters, the acrylic pieces of glass that are very handy to have around for mixing or splitting different sources of light, especially if you're working with lasers like I do. They're handy for mixing those different laser colors together. Aside from that, I don't know what much use they have. First surface mirror right here. First surface glass, mirrors and stuff like that. Very handy to have when you're working with high precision optics. Got the DMD, a digital micromirror device. That's not much of a use to me, and you know, it looks cool. and can go on the desk with the other junk that starts conversations, but aside from that, no real practical use in my case. Let's see what else. We got the front lens assembly. So same thing as most projectors and cameras. You can see how it works. It's basically little slots in this section here, and when the optics get moved in those slots, they ride back and forth in their carriers, the rings. So a little bit of a cam action going on there. And same thing here too for the other section. So one of them is going to be for the focus, and the other one is going to be for the zoom. Betting this is the focus, and this is for the zoom. Nice little assembly the way it is. I'm going to keep it together. Got this piece right here, and it just has a polymeniscus biconvex lens, and it's a weird lens. It has one of the corners cut out to make a path for the light that comes off the DMD. So the fact that the lens is kind of cut at that corner doesn't make it very useful. There's another little lens in here that I might pull out later, but yeah, not much really, honestly. Let's take a look at these. Oh, little button board, that's nice. I like these little metal buttons. They're great for little projects, and they're nice and thin. Main board, got the digital light processor itself, so this handles all the decoding and encoding for running the DMD. And on this side, that looks like we have some kind of a RAM here, so where the DMD card sits. Looks like a voltage regulator of some sorts right there. Let's see, where does power come in? Power comes in over on this section here. So very little as far as voltage regulating hardware. DC to DC converters. There's not much going on there at all. Surprising. Yeah, not much to this board. Let's see. That chip could be for analog inputs. So the VGA and the RCA, analog digital converter. Yeah, not much going on. The lamp inverter. It's a pretty nice lamp inverter, as it looks to have 4 MOSFETs, so full H-bridge output, which is more preferred than having just a half-bridge output for driving transformers. Eventually, I like to figure out how to hack these things, because they'd be good little drivers. But that's another project for a different day. And the best thing out of this whole unit, I think, is this power supply. The excellent form factor looks to be about 9 inches by 2.5 by about 2 inches. Yeah, about that. So this will be useful for things. And this probably puts out, as I said, 5 through 24 volt rails for driving everything. Probably quite a few voltage rails, given the lack of voltage regulation and DC to DC drivers on that other board. And then finally, a nice piece of perforated steel, or what some would say, a pretty great. I like the hexagonal cutouts. I want to see what kind of patterns they make with the laser interferometer. Yeah. That's about it for this teardown. Not much inside of the projector, so that's where I'm going to leave it. I hope you enjoyed, and as always, stay tuned for more.